Hello and welcome. The topic for today is serious for further mathematicians. It's actually enrichment. This particular question that I've got up there is actually a 5-star question. So, and I've got the solution here. I wrote it only last night. I don't think you can actually see, maybe not in focus, maybe too small. I wrote it only last night. My wife was watching a period drama on Henry VIII. I was a little bit bored, so I decided to use my time differently. So I came up with this particular question purely because a few of you have been asking me to do more questions on double sigma. So they're quite fun, these ones. They're not that difficult. They look very scary, but they're not. This particular one is suitable for further mathematicians, as I mentioned. And if you overcome the initial shock of looking at this, it requires nothing more but the standard summation formulas that are taught at further maths. I'm not quite sure nowadays what they call the modules and what exactly they are. Okay, so let's see how we're gonna do this particular one, step by step. With questions like this, it's good to start from the inner bit. So the inner sigma, if you want, the inner summation. So I'm merely writing the outer sigma first of all. N is equal to 1 to 9. And now we're going to concentrate on this particular part. Because we have two items, we're going to use the linearity, if you want, of the sigma operator. And I'm going to write it as 2 sigma from m is equal to n plus 1 to 2n of, put the 2 on the outside. I'm writing 2 again like an idiot. M, so that is the 2m bit, plus the same thing, m is equal to n plus 1 to 2n of n. Let's observe a couple of things. First of all, I cannot pull this m on the outside because the dummy variable is m, so this sum is running m, so it has to stay inside. However, for this particular one, the dummy variable is still m, so these n's are constants, and therefore this particular n is independent of m, and therefore it can go outside, and I can write this as 1 inside the sum. Okay, how do I find now things which look like that? What makes it difficult is the fact that it is written in not the usual letters that we're familiar with. I'm going to write a formula which we all know, but I want to write a little bit differently using different letters. I'm still going to use r is equal to 1 and r, but instead of putting n here, which is the usual letter, I'm going to use k because the n is used for something else in here. It's going to look very, very confusing otherwise. So the sum of basically integers, we should all know this is a half k plus 1. And just in case we need the other one, I think, just try to think ahead, I think we will need the other one as well. I'm going to write it from now. The sigma r is equal to 1 to k of r squared is of course 1/6 k plus 1 to k plus 1. And of course all of these formulas are usually given in formula booklets for every board in the UK, so you don't have to worry if you can't quite remember, is it the 6th, is it the 3rd, or whatever. All right, so I'm going to now concentrate on this summation. Let's look at the first one. It's a shame it doesn't start from 1, because if we started from m is equal to 1, of course I'll be using straight away this thing here. So what does that actually say? It says sum from 1 all the way to 2n, and then take away, in order to be left with the n plus 1th, if you want, term inside, you need to subtract the first n terms. And similarly for this particular one, whatever this sum is, let's call it t so we don't confuse. This is the s I'm using for this and capital T for that. It'll be the t of t's label tn minus capital T n. So the question now is, what are these things? Let's concentrate one at a time. First of all, I'm going to use the formula for and hope we can see the board if I write here, for the sum of 2n of integers. So I'm using this formula from 1 to 2n. That, of course, is going to give me, first of all, let's not forget the outer sigma, which is lying there, is 9 on the top, n is equal to 1, and all of these things are going to be inside this argument. We have, of course, 2, lots of that, so it's going to be a half. Let me just write it and then we can check it's all correct. 2n bracket 2n plus 1. All I'm doing is I'm using this formula where k is 2n. So that's this bit here. And the 2 is because it was in front of the sum that I had in there. But from that, I need to subtract exactly the same thing, but now where the top is the k is in fact n. So I still got the 2, that's the 2 at the front, times a half n plus 1. So far I've dealt with this particular term. I've still got him. What does that mean? I'm adding ones, 1 plus 1 plus 1 plus 1. How many I'm going to add? Well, if I see what is the difference between 2n, and don't forget I'm counting the n plus 1, it's the same thing. You should be able to see it from here. It's 2n take away n. I hope you can see that. It's enrichment material. It's very, very difficult to explain. I can't just throw loads of dots in there and try to convince you, but I hope you can actually see this from, if I start from n plus 1 and finish at 2n, there are n terms in there because, of course, I need to take off the first n, and from 2n to n is n. So let's not forget, first of all, we have a plus n. This n is the n on the outside, and that's how many ones I will need to add. Minus 2n minus n. So this is this sigma here. There should be, of course, 4 in total in there because we've got subtractions, but I wrote this one compactly because it's so simple. So it's going to be that take away that plus that take away that. And this, of course, is something that we need to tidy a little bit at this moment. So let's make a bit of room. We don't need this anymore. So I hope you're following so far, and I do say this is not obviously the kind of stuff you anticipate to come up on your exam. If you come down your exam, there's going to be a lot of people that will be crying, probably be riots up and down the country or something. This is enrichment, so it's just to show you what you can do with stuff that you already know, but going a little bit on the harder side. So n is equal to 1 to 9. 2 times a half, goodbye. 2 times a half, goodbye. And let's hope I don't make mistakes. This n looks like a h, very bad. So this is gonna give me 4n squared plus 2n, and this has gone by going minus, so it is minus n squared minus n, and this one is, of course, n in there times n is plus n squared. So this is now all of this line simplified, which of course it will simplify further to something even nicer, and after that it becomes very, very easy. This n squares can cancel, so that will give me 4n squared plus n to be evaluated. Again, split into 2 sums, so 4 sigma from n is equal to 1 to 9, I'm going to move out of the way in a second, of n squared, so that's the split, plus another sigma, this is the n item, n is equal to 1 to 9. And I wish now I had brought my calculator because it's quite tedious. I very rarely use a calculator. I'm fairly numerate, although as I'm getting older now, I do make a lot more mistakes. My brain's not what it used to be. So so this is now, I need to use this formula which I wrote, where we can actually write it in n now because it doesn't really matter. It's going to be 4 times my k is 9, so it's going to be, first of all, the 1/6 at the front, so we got 9 times 10, 9 times 10 times 19, plus this is the sum of integers, so it's going to be a half, n is 9, 9 times 10. I'm sure we can do that without a calculator. It doesn't look too bad. 4 6 is 2/3. 2/3 of 9 is 6. So that's 6 times. That's the 6 times 10 times 19. And that's, of course, another 45 from this. And we got 60 times 19 plus 45. So 60 times 19 is 1,200. 1,200. Take away a 60 to make it into, so that's this term here, plus 45. So that should be 1140. 1185, I think, is the correct answer. If I made a mistake, please just put it into your calculator. But I think I actually have the answer. Where did I put it? Somewhere here. There you go. 1185 is the correct answer. So we've done it correctly, and I hope you understood how to do a question like that. It's of course a little bit challenging, but not as bad as it first looked. And on that note, we are definitely laughing now, all of us.